Hi class, okay, so today we are going to continue with lecture 2. Okay, what we should learn in lecture 2. So, this is the third subtopic of this chapter, which is the trapezoidal rule. So, at the end of this lesson, students should be able to use the trapezoidal rule to approximate definite integral. So, now we want to find the definite integral by using the trapezoidal rule. Okay, what is the purpose of this subtopic? Okay, to find the approximation solution. So the key words here is approximation for the definite integral when the exact value of definite integral cannot be found or difficult to solve by using the integration technique. As we know, we've learned so many techniques in the chapter 1 to solve for the integrations. So we have the basic formula, and then we have the special formula, and then we have the substitution method, the by-part method, and then we can apply the partial fraction to solve the integration. But we need to use this approximation method because we cannot find it by using those methods we've learned in chapter 1. For example, we want to integrate e to the power of x squared respect to x from 0 to 1 and integrate square root of x to the power of 5 plus 1 respect to x from 2 to 4. Both of these examples cannot be integrated by using simple integration. You may try on your own by using maybe substitution method or by-part method. Okay, so it's up to you lah. You can try and see whether you can solve it or not. Okay, so trapezoidal rule is one of the numerical method for estimating the integration of fx respect to x from a to b. So what is trapezoidal rule? So to find the area bounded by the curve y equal to fx, so we know we are trying to find the area by using the integration, right? So the area of this bounded this area is this region bounded by the curve from a to b is denoted by integration of fx respect to x from a to b. The area A under the curve y equal to fx bounded by x equal to a and x equal to b is divided into n strip with equal width. Okay, so we are dividing this area into a number of strips, and then the strip must have equal width. So the distance between this value x0 and x1 should be the same as the distance between x1 and x2, which is the same as x2 and x3 and so on up to xn. So our x0 is the a, the limit, the lower limit, and xn will be the b, the upper limit. So what we can see that if we know what is the area for each of the strip, then we can total up everything to find the area under the curve. Means that the area under the curve is equivalent, approximately equal to the sum of area of n trapezoid. So this small strip is a trapezoid. Why? Because we have a width and two parallel sides but different length. Okay, so let us see how this trapezoidal rule applied in finding the area. So let y0, y1, y2, y and so on up to yn be the values of the function fx at ordinate x0, x1, x2, xn respectively. Means that at x0, then the value of y should be y0. So this point, the coordinate here has a point x0, y0. Okay, so for x0 we have the length of y0, and then for x1 the length here should be y1 and so on. Okay, and then we know the area of trapeziums is given by 1/2 multiplied with width multiplied with the sum of two parallel sides. So let's say we want to find this first trapezoid. Okay, so we have this width, which is, as we said earlier, the same equal width, which is equal to h, and then we know this length is equal to y0, and then the other side length is equal to y1. So what is the formula to find this area? So this is equivalent to 1 over 2 multiplied by h multiplied by the sum of two parallel sides, which is y0 plus y1. Okay, that is for the first strip. How about the next strip? Okay, so let's see how we do for the other trapezoidal. So the area, as we found earlier, A1 equal to 1 over 2h multiplied with y0 plus y1. And then the second and the third area will be A2 equal to 1 over 2h of y1 plus y2. A3 is equal to 1 over 2h of y2 plus y3. Then, if we continue the process, we will have the one before the last strip will be a of n minus 1 equal to 1 over 2 multiplied by h multiplied by 1 y of n minus 2 plus y of n minus 1, and the last strip will be an equal to 1 over 2 h multiplied with y of n minus 1 and plus with yn. So to find the area under the curve means that we have to find the sum of all the trapezoids. So means that add up A1, A2, A3 up to AN. So what we have for A1, A2, A3 and so on up to AN. So we have this 1 over 2h multiplied by y0 plus y1 plus 1 over 2h multiplied with y1 plus y2 and plus and up to 1 over 2h of yn minus 1 plus yn. So if we see here, we have a common factor 1 over 2 and h means that we can factor out the 1 over 2h. And then what's left inside the bracket? So we have y0 plus y1 plus y1 plus y2 plus y2 plus y3 plus and so on. Lastly, y1, yn minus 1, yn minus 1, yn. So as we can see here, we have only ones of the y0 and yn, but a double of y1, y2, y3 up to yn minus 1. So what we can conclude here, the area can be written as, this is the formula of the trapezoidal root. So it is equivalent to if fx is continuous on interval a to b, then the integration of fx respect to x from a to b is equal to h over 2 multiplied with y0 plus yn together plus with a double of y1 plus y2 plus y3 up to yn minus 1. Okay, so what is n? N is a number of equal width subinterval, or as we said earlier, the number of strips. Okay, and then what is h? H is the width of each subinterval, the width of the strip. How we find the width? The width, we subtract the upper limit with lower limit and divide with how many strips we want. Okay, so take note that 4 strip is equal to 4 subinterval, means that n equal to 4. But 4 ordinates only give you n equal to 3. Why? Ordinates means points. So how many points? 4 points. So how many strip we have? So 1. So we have this line. So how many strip? 1, 2, 3. So please take note of the terms of strip, subinterval and ordinate. So let's do some example. Example 1. Evaluate the natural log of x respect to x from 2 to 6 with 4 strip or 4 subintervals by using trapezoidal rule. Give your answer correct to 4 decimal places. So I know that all of you know how to integrate natural log of x, but now we want to evaluate by using trapezoidal rule. We have to follow the questions. So how to estimate the integration of natural log of x from 2 to 6. Okay, notation. Working must have 5 or more decimal places. Why? Because the question asks you to give your answer in 4 decimal places. So that is the last step you should do, which is round off to 4 decimal places. So first step we should know is what is the importance information we should take note. The first one is the number of sub-interval or the number of strip, which is equal to n. So how many n we should have? Following the question, it asks you to find by using 4 sub-interval. So n is equal to 4. And then what is a? A is the lower limit, which is equal to 2. B is the upper limit, which is equal to 6. And then the next step is to find what is h. How to find h? So by using the formula b minus a over n. So b 6 minus 2 over 4. So 4 divided by 4, which is equal to 1. Okay, now we go to the step 3, which is to list out all the value of x. So because the x is started with 2, so the next value of x, which is x1, should be added up by h. So what is our h? Our h is equal to 1. So x1 is equal to, okay, so now they calculate the value first. So if I am the person answering the questions, I will list out all the value of x and then confirming that it includes the lower limit and upper limit. So it should be here 2 plus 1 is 3, 3 plus 1 is 4, 5 and 6 should be the xn, the last number, which is x4, because our n is equal to 4. Okay, it's okay. So just follow the PowerPoint. So here they directly find what is y0. The next one is x1, which is 3. Why 3? Because 2 add up with the h. So when x1 equal to 3, y1 is equal to, we put on the other column. Why? Because y0 and yn only should be in this column. This one should be in the middle. The value y in the middle. Okay. So the next one should be x2. So x2 is equal to 4, y2 equal to 1.3, and then x3 equal to 5, and then we have y3, and then x4 equal to 6. So we have y4 in the second column here. And then what we should do? We add up the values of y in respective column. So what we have for the first column, we have total up y0 and yn, which is y4 equal to 2.48491. 5 decimal places, and then y1 plus y2 y3, so we get 4.09434. Now just transfer all this value into the formula. Okay, what do we have? Okay, by using trapezoidal rule, h over 2. So what is h? H equal to 1. And then what is y0 plus yn? So we have found it in the table, which is 2.48491, and then plus with 2 multiply with y1 plus yn minus 1, which is we found in the second column, which is 4.09434. So this is the marks for the transferring of the information calculated into the formula. And then just give your final answer, which is equal to what? 5.3368, and then this is 4 decimal places. Notice our working all in 5 decimal places, but we give the answer in 4 decimal places. Okay. So the next example, approximate the integration of square root 1 plus x respect to x from 3 to 5 by using trapezoidal rules with 4 strips. Means 4 strip is 4 sub-interval. Give your answer in correct to 4 decimal places. So the step we use here, the same as the previous question. First of all, what we need to do is to find the value of n. So what is n? N is equal to 4. And then what is a? So our a is equal to 3. What is b? Our b is equal to 5. And then the next thing should find is h. So what is h? B minus a divided by n. So 5 minus 3 is 2. 2 divided by 4 is 0.5. So if you want to do the table, because we have 4 sub-interval, means that we have x0 up to x4. So our table here, so I will write down what is my x first. Okay, so we have x naught, which is equal to, starting with 3, and then I will have x1, which is equal to 3 plus h, 0.5, and then the next one is x2, which is equal to, oh, this is 3, sorry, okay, did I erasing everything here? Sorry, okay, so this is my table. So this is 3, next one is 3.5, the next one 3.5 plus 0.5 is 4, and then should be x3, which is equal to 4.5, and then x4 equal to 5. So why we stop at x4? Because n is equal to 4, and then make sure that xn is equal to the upper limit of the integration, so which is equal to 5, so it's correct. So we can stop here, and then the last row should be the total. Okay, so what I should do is to divide this into 2 columns. So y naught and yn, which is y4, should be in the first column, and then the other 3, which is y1, y2, y3 should be in the second column. So as I said in the first, for the Newton-Raphson, we can use calculator to directly calculate this value. So how? You use the calculate function. Okay, so we have the function square root of 1 plus x, and then you put calculate and you substitute the value of x, which is 3, and then equal, so you get the value for y naught, and then put calculate again, but don't put answer. We substitute the value of x, 3.5. okay, so it's not like the numerical, but we can use the same method of the calculator. Okay, so let's see the working here. So let me clear out all these scribbles. So we see what is the step we are doing here. First, n for a 3, b 5, and h equal to 5 over 3 minus 4, which is equal to 0.5. The next step is to do the table. So do as I said earlier, and then total up for y0 and yn, and y1 plus y2 and y3. Okay, and then what we should do, just transfer all this value into the formula. So what is the formula? H over 2 multiplied with y0 plus yn, which is we have the total already, and plus with 2 of y1 up to yn minus 1, which is we also have the total. So it will be 0.5 divided by 2 multiplied with 4.44949 plus 2 multiplied with 6.70260. So as I said earlier, 5 decimal places, so just write down the 0 here, and then what we have as the answer, it should be 4.4637, which is 4 decimal places. Okay, the next example. Do you think you guys can do on your own? So we want to use the trapezoidal rule with 5 ordinates. 5 ordinate to estimate a square root of sine x respect to x correct to 4 decimal places. What is this value? What is this value here? Okay, you guys. Okay, let's see. So because this is a sine, means that we have to use the mode radian to calculate the value. Okay, so what is the first step? We have a equal to 0 and b equal to O. So this is pi. Sorry for the confusion. So b is equal to pi and n is equal to 4. Why 4? Because 5 ordinates is the point. So 5 point will build up 4 strips only. So how many strips? 4 strips means that n equal to 4. And then the next step we know is to find the value of h. So what is h? B minus a over n. So h equal to pi minus 0 over 4, which is equal to pi over 4. Okay, so pi over 4. Okay, now to put into the table, so we have the y equal to square root of sine x, and then list down all the x. So x naught starting from 0, and then calculate the y. We have square root of sine 0, which is equal to 0. And then x1 should be 0 plus pi over 4, and then y1 should be on the second column. Don't forget to put, yes, mode must be in radian mode. So it's square root of sine pi over 4. And then the next one, x2 should be 2 pi over 4, because pi over 4 plus pi over 4 or pi over 2. Okay, so what we have here, y2, which is equal to square root of sine of pi over 2. And then the next one is x3. So what is our x3? x3 is 3 pi over 4, so y3 equal to 0.8409490, and x4 should be pi, which is the upper limit, which is y4 equal to 0. Sine of pi is equal to 0. So now total up the first column and the second column together and transfer the information into the formula. So by using the trapezoidal rule, we have pi over 4 multiplied by 2. Why? This is pi over 4 divided by 2, which is equal to pi divided by 4 multiplied by 2. Right? Pi over 4 multiplied with 1 over 2. Right? Okay. And then what is y0 plus y4? It's equal to 0. And then y1 up to y3 equal to 2.68180. So the final answer should be in 4 decimal places, which is 2.1063. Done. Tips here, the value of x is in radian. Why radian? Because our limit's in radian form, pi. If the question gives you from 0 to 180 degrees, then we have to make sure that the mode should be in the degree. Okay. Example 4. So this is the kind of question in the examinations. Okay. The region A in the first quadrant of the plane is bounded by the y-axis, the x-axis from 0 to pi over 2, and the curve y equal to 2 multiplied with square root of 1 minus cos x multiplied with sine x. The question is, first, find the area of A with integral method. So what we need to do, the first question asks you to use your knowledge in integration. Okay, and then the second one is by using the trapezium rule or trapezoidal rule with three interval each of width pi over 6. So it's given the h already. To estimate the area of A, giving your answer correct to 3 decimal places. And then the last one is calculate the percentage error in your answer. Okay, this is the usual question in university. So you will learn what is the importance of the percentage error. Okay, let's do the first part of the questions. So now we want to integrate, right? The question is to integrate. Integrate 2 of square root 1 minus cos x sin x dx from 0 to pi over 2. What we can do is to use substitution method. Why? Because under the square root is 1 minus cos x, which is if we integrate this, we differentiate 1 minus cos x, we get sin x. That's why we let u equal to 1 minus cos x. So du dx equal to sin x. So rearrange dx equal to du over sin x. Now substituting everything with 1 minus cos x with u and dx with du over sin x. So we have a square root of u respect to u. But this is for you. This limit 0 to pi over 2 is for x. So to change directly the limit from x to u, we just have to replace the value of x into the function. So what is our u function? 1 minus cos x. So when x equal to 0, u will be 1 minus cos 0. So what is cos 0? Cos 0 is equal to 1. That's why 1 minus 1 is 0. So the lower limit is 0 when x equal to 0. When x equal to pi over 2, u equal to 1 minus cos pi over 2. What is cos pi over 2? It is equal to 0. So 1 minus 0 is 1. So when x equal to pi over 2, u equal to 1. That's why we are integrating square root of u respect to u from 0 to 1. Now integrate u to the power of 1 over 2, we get u to the power of 3 over 2 divided by 3 over 2, which is multiplied with 2 over 3. Now just substitute the limit because the limit is already in u. So what do we have as the answer? Will be, yes, 2 over 3 can factorize out. So replace 1 and 0, we get 1 only. So the answer should be 4 over 3 unit square. Okay? Okay, so now this is the first question A. The next question B, they ask you to use the trapezium rule or trapezoidal rule. So it's given the value of h already, and then we know what is A. What is A? A is equal to 0, B is equal to pi over 2. And then n is equal to 3. So substituting the x. As we know, what is our x? What is our x? So we start with x equal to, technical error. Okay, so what is our x? The first x should be what is our x? So it's to start with 0 lah. Okay, x0, x0 is equal to 0. So y0 is equal to, substitute the value, cos 0 is 1. So 1 minus 1 is 0. So 0 multiplied by 0 multiplied by 2 is 0. And then x1 should be 0 plus pi over 6, which is pi over 6. So y1, we put on the second column. Remember that we have to use mode radian. Why? Because the value of x here is in radian. In pi means that it's in radian. And then x2 is equal to pi over 3. So y2. And then x3 should be pi over 2, which is, because the n is equal to 3, right? So this is the upper limit, pi over 2. Should be the same as the questions. So y3 is equal to 2. y2, cos pi over 2 is 0. Sin pi over 2 is 1. So 1 minus 0 is 1. Square root of 1 is 1. 1 multiplied by 1 is 1. 1 multiplied by 2 is 2. And then total up each column. So we have 2 and 1.5907. Now put everything into the formula. So we have by using the trapezoidal rule, integration of 2 square root of 1 minus cos x sin x dx, from 0 to pi over 2 can be written as h over 2. What is h? H is pi over 6. So pi over 6 divided by 2 is equivalent to pi over 12. And then multiply by y0 plus yn, which is equal to 2, plus with 2 multiply with y1 plus 2 up to yn minus 1, which is 1.5907. Now, using your calculator, you get the answer 1.356, which is, following the question, they ask you for the 3 decimal places. So, we are done with the question B. Now, question C. How to find the error? Okay. So, the error is the difference between the exact and the approximation. So, we can use exact minus the approximation or approximation minus the exact. So, we know the exact value we found in part A is equal to 4 over 3. And then the approximation equal to 1.356. And then we put the absolute value here because we want to find the percentage of error. Okay, so exact minus approximate, 4 over 3 minus 1.356, we get 0.0227. And then for the percentage, we have to multiply with 100. Divide with the original value. Okay, so this is the difference between original and the approximation, and then we have to divide with the original and multiply with 100%. So what do we get here? 0.0227 divided by 4/3 multiply with 100%, we get 1.703%, which is really small error. Why do you think? Yes, because the area we approximate is a trapezium, but it can be area that we didn't include. Okay, that's why we have some errors. Okay, so that's all for lecture 2 of chapter 3. Means that we've done with chapter 3. So if you have you should have some time to practice this exercise to make sure you understand all the concept in trapezoidal rule. So that's all for chapter 3. Thank you.